So we'll start with the remaining properties. So yesterday we have discussed linearity and time shifting. So today we'll discuss scaling in Z domain. Okay. Okay, what is scaling in Z domain? So if we have the signal x of n input signal and its Z transform pair which is x of Z. Okay. Now if we have the scaling factor alpha power n into x of n at the input side, then this signal, if we take the Z transform, then it will be scaled by this factor, that is alpha, okay, in the Z domain, that is x of Z by alpha you will going to get. Now if we have the ROC R, so in this case, in this case whenever it is scaling in the Z domain, the ROC will be equal to, so that is with the ROC alpha times R. So whatever the scaling factor in the time domain, so the ROC will be alpha times that ROC, whatever earlier ROC is there. Okay. So now we are going to prove this. So you can take the x of Z, okay, which is equal to n equal to minus infinity to plus infinity x of n into Z power minus n. So this is a standard expression. Now this signal I will take this whatever input, so then I will replace this x of n by this factor. Okay. Now what will be going to get for this signal, we will see. Okay. N equal to minus infinity to plus infinity. If I have the scaling factor in term domain, okay, alpha power n into x of n into Z power minus n. Now you can see alpha and Z we can combine here. So we will going to get n equal to minus infinity to plus infinity x of n into alpha into Z power minus n minus 1 whole power n. Okay. So now we can write this one. This in general you can see here, this we can write it as x of Z. Okay. So is it not? So now, so what is the factor in place of Z which is having? So it is nothing but Z power minus n. So here, so instead of Z power, so whatever the value of Z is there, here instead of it is alpha into Z power minus 1. Okay. So now we can, so what we can write? So this one we can write it as x of, so Z by alpha, because here the factor which is going to scale by alpha. So in the Z domain we can write it this one as x of Z by alpha. Okay. So this is about the proof. So just you replace the value of this alpha and Z, you combine, and we can compare this with this equation and we can write this one. Okay. So here, and also alpha is a complex number. So that is very important. Alpha is a complex number. Okay. So this is how we can able to get the proof for this. Similar like here, so sorry, here it is alpha inverse into Z. You can see here, so we need to put Z power minus n, so whole power minus n if you want. So alpha inverse and Z, this whole power minus n, then only we will get Z by alpha. Okay. So is it understood? So you can see here, so alpha inverse into Z, so then only we can get Z by alpha. This is whole power minus n. So now if we can compare this, and we can write this x of Z by alpha. Okay. So this is what scaling in the Z domain. So now instead of, if we put instead of alpha power n, if we put instead alpha power minus n, then what is the scaling factor in the Z domain? Can anybody tell? Hello? Can anybody tell if it is nothing but if any instead of alpha power n, if I put alpha power minus n, what will be the result?
X of alpha Z.
Yeah, so x of alpha into Z it will going to come. So that is what the scaling it will happen in the z domain. Okay. So, even both of them they can ask. So, either alpha power n or alpha power minus n. So, similar kind only you have to prove this. Okay. Now, this is about the scaling in z domain. So, now next property, okay. So, the next one is time reversal. Okay. So, what is mean by time reversal? If we have, so again the transform pair x of n with x of z. Now, if we have signal x of minus n, that is the reverse in the time domain, that is, so about the origin it will going to the reflection of the signal. So, if we have like this time reversal, then what is its corresponding z transform? So, this will going to give 1 over z, x of 1 over z. Now, if we have the ROC here for this case is r, then in this case it will given, so it is 1 over r. So, that is what the time reversal. Now, we will going to prove this. So, take the expression of x of z summation n equal to minus infinity to plus infinity. So, now, so in order to prove this one, so we know x of n into, so z power minus n. So, now we will take LHS. So, that is inputting the signal with x of minus n. So, take the same z transform equation, input the signal which is x of minus n into z power minus n. Now, we can put n equal to minus L. So, what will going to get? So, if I put n equal to minus L, so then your L will become equal to, so minus n. So, we can replace that. So, that will give summation n equal to minus infinity to plus infinity. So, if I change L value, so that is from n to L variable. Okay. So, L it will going to vary from plus infinity to minus infinity. So, then it will give x of L into z power plus L. Okay. So, now this summation, so again it is look like as like this summation only. So, which is L equal to minus infinity to plus infinity x of L. So, this one we can write it as z power minus 1 minus whole the power minus L. So, in order to bring in this form, okay. So, I am putting it as x, so z power minus 1 whole power minus L. So, now if we can compare this with this equation, we can write this. So, instead of there is a z, so here z inverse is there. So, then we can write x of 1 by z. Okay. So, here it will be z power 1 into whole power minus n. So, here instead of that we will be having z power minus 1 whole power minus n. So that we can write the z transform, it will be x of 1 by z. Okay. So, is it understood? If any doubt you can ask. Okay. Now, this is the time reversal. So, that is if we have the time reversal of signal, its corresponding z transform will give x of 1 by z. So, this is what the result.
Hello, sir.
Yeah.
Sir, here why we are using n is equal to minus L, sir?
So, even in order to bring that, in order to find out the corresponding z transform, because we cannot put directly for this, we do not have any standard expression to put the x of z. Okay. So, we have the standard expression for finding out the z transform, this one. We have to bring it to this form and then we have to find out its corresponding z transform. That is why we are putting the variable, put n equal to minus L. Okay.
Okay, sir.
So, even it is a left sided signal, right. So, not to bring that, so to the form which is already standard expression. So, we are putting the, so n equal to minus L variable we are substituting and we are finding out the z transform. Okay. So this is about the time reversal. Now next property is so the time expansion. So in the time expansion, so we know that x of n k and x of n by k, that is so the scaling factor here. So the time expansion and compression, so that we have known the signal, if it is having like, if we have the signal like this, so if it is nk, it will going to compress, okay. So like this, if it is minus 2 to plus 2, so if this n, that k value is 2, then it will going to give compression value between minus 1 to plus 1, like that, okay. Even expansion, so if the same scaling factor is there 2, then you will going to get minus 4 to plus 4, like that, okay. So there is a time expansion and that is time compression. So here in this property we will going to see, so what is time expansion. If we have the signal x of n, so and its corresponding z transform x of z. Now if we have the signal, either you can take this or this, okay. So n by k, if I take the time expansion, since we have taken time expansion, we will take x of n by k. Then what is this corresponding z transform? It will going to give x of z power k, okay. So with the ROC, so here ROC will be, if it is R, so in this case ROC will be equal to, so R power 1 by k. So whatever the scaling factor is there, so k, it will become R power 1 by k, okay. So now here, so we can directly write that, so x of z power k, okay. Instead of here, so in the standard expression what we have, x of z, so we will be having x of n into z power minus n, okay. Here instead of z, so we will be having z power k, because it is the expanding factor, so it is in the z transform, it will be multiplied by that factor. So x of z k, we can write it as summation n equal to minus infinity to plus infinity x of n. So this n by k, again, so the same thing, so instead of putting x of n, so we are finding out the, so the z transform for this signal into z power minus n. Now we can put n by k variable for another variable and we can get it. So that x of z power k will going to get it as like this, n equal to minus infinity to plus infinity x of something like another variable like x of l or something like that, if you take, and you can, so if you put l equal to n by k, okay. So now, so here put n by k, it is l. So if you put n equal to l into k, so like that you can put the variable name. So instead of n, so we will going to get lk, that is minus l into k, okay. So now here you can see, so this form again we can, so this again l will be varies with between again minus infinity to plus infinity, that will be there. So if you take n equal to minus infinity to plus infinity, l will also vary between minus infinity to plus infinity. So this we can write it as again, so summation l equal to minus infinity to plus infinity x of l into, so you can see here, so since l is the variable, so now we need to bring in this form, that is z power k whole power minus l. So you can see, so we can compare this with this standard expression, so which is there here itself. Instead of z, here z power k is there, so that's why its z transform is x of z power k, okay. This is how the proof will going to come. Now instead of x of n by k is there, if it is x of nk, that is time compression, so what will be the result? Can anybody tell? Hello. If nk is there, so here just put the value of l So, if it is n k, what will be the n? It is L by k, right? Is it not? So, that means, so it will going to give z power, so that is 1 over z power k. So, that it will going to give, so 1 over z power k, that is what you will going to get, is it not? So, just if you can replace here, so instead of n, L by k. So, if you put L by k here, you will going to get z power 1 over k. So, that is what you will going to get for the, so x of n k. Is it clear, or I need to do that? Is it understood?
Yes, sir.
Okay. So, this is about the time expansion. So, now next one is the conjugation. So, just this is just remember the result for this conjugation. There is no need of proof of this. So, if we have x of n which is having a z transform pair x of z, if we complex conjugate the input signal x of n, then the corresponding z transform also it will get the complex conjugate in the z domain also. So, in this both the cases ROC will remain same, which is equal to R. Okay. That is, any 0 or pole in this real signal, say for example, at z equal to z naught is there, any 0 or any pole is there. Then in the complex domain also, so it will take the complex conjugate of that point. Okay. So, that is what, so the complex conjugation of the signal. So, this result just you remember for this. So, there is no proof is required. Okay. So, this is about the conjugation, and now, so we will go to the next one that is important. So, it is convolution property. Okay.
So X conjugate and Z also is conjugate, no sir?
Here,
Yes sir.
what you asked?
Z also conjugate, sir. X conjugate into Z also
Yeah,
conjugate.
here,
Yes sir.
because we are taking at that particular
Yes,
point
sir.
conjugation,
Conjugate.
x star of z star. Yes.
Yes, sir.
Yeah, clear. So, yeah, so it is a Z conjugation. Okay. Okay. So, next it is the convolution property. So, now if we take two signal, so the convolving each other, and what happens in the Z domain. So, that is what the property. So, let us take two signals, one is x of n with its Z transform pair x of z, and another one y of n with its Z transform pair y of z. Okay. So, now if we convolve these two signals, that is x of n convolution y of n, then what is the resultant of this one, the Z transform? So, the resultant will be multiplication of these two Z transform, that is x of z into y of z. Okay. And if we have the ROC R1, if I take this one and this is R2, then the resultant ROC which will be R equal to, that is R1 intersection of R2. Okay. So, this is what the convolution, and even we can take this. So, the two signals which is convolving each other, we can take it as something like, so any W of n which is equal to the convolution of these two signal, and we can arrive the, so the resultant W of z. Okay. So, now take this and we will try to prove this one. So, take the input signal which is a convolution of these two signals. I need to find out what is W of z. Okay. So, I will take, so that the W of z equation which is n equal to minus infinity to plus infinity, W of n into z power minus. Now, I will substitute the W of n, so which is equal to n equal to minus infinity to plus infinity x of n convolution y of n, okay, into z power minus n. Now, so we can write the convolution equation, so x of n and y of n. So that convolution equation, so once we write, then we will going to simplify that. Summation n equal to minus infinity to plus infinity. Now I will write the convolution equation, so which is equal to k, I will take the k variable minus infinity to plus infinity x of k into y of n minus k. Okay. So this is a convolution equation I am taking for x of n convolution y of n. This whole thing, so which is multiplied by z power minus n. Okay. So now I will just interchange the summation. So I will take out this one. Okay. So this one outside, summation k equal to minus infinity to plus infinity x of k, and I will take this inside the summation n equal to minus infinity to plus infinity y of n minus k into z power minus n. Now I will put the variable for n minus k. Okay. So put variable n minus k which is equal to L. Then what will be the n value? N value will be equal to k plus L. Now if I put n minus k which is equal to L, L is also varies between minus infinity to plus infinity. Okay. So this we can write it as summation k equal to minus infinity to plus infinity x of k into, now summation L equal to minus infinity to plus infinity. I will replace this n minus k with the L, y of L into z power. So this n will be equal to now k plus L, minus of k plus L. Okay. So now I will rearrange the terms, so which will be equal to summation k equal to minus infinity to plus infinity x of k. Now we can see this z power minus k into z power minus L I can write. So this z power minus k I will take into the first summation. Okay. And similarly, so remaining summation I will put it as it is, L equal to minus infinity to plus infinity y of L into z power minus L. Now you can see, so this will be the standard expressions like x of z. So it is x of n into z power minus n. Similar like here only the variation is the variable is k. So it is x of k into z power minus k, and here also it is the variable instead of n, it is here it is L. It is y of L into z power minus L. So we can write this one as x of z and this one as y of z. So that is what we require. It should be a multiplication in the z domain. If it is a convolution in the time domain, okay, its corresponding z transform will be the multiplication in the z domain. Okay. So understood? Any doubt in this? So this is what the convolution property. Yeah. Okay. So that is the convolution property, and so next one is differentiation in z domain. So what is meant by differentiation? So how to get the differentiation in z domain? That is what the requirement here. What we need to do in the time domain so that we can able to get the differentiation in z domain. Okay. So for that, so if we have x of n with the z transform pair x of z, now if we scale the factor, that is if we scale the input by a value of n, okay, so now its corresponding z transform will be equal to the differentiation happens, that is minus d minus z into dx of z by dz. Okay. So again here the ROC will be R, and here the ROC remains as it is. Okay. So only the change is if we scale the signal in the time domain, so then it will be a differentiation in the z domain, corresponding z domain it will be having a differentiation. Now, we will take this signal and we will try to get the Z transform of the same. So, I will just take this one as something like x1 of n, or else directly I can take this. So, let us find out the Z transform of this, that is summation n equal to minus infinity to plus infinity. So, I will replace the input x of n into, that is n into x of n into z power minus n. Okay. So, now that I will take it as x of z, because this is a Z transform of the, okay. So, here directly I will take x of z and then I will go. So, this is the standard expression x of z, because first I need to differentiate this one. So, instead of directly putting this signal, I will take this side, that is RHS side, and I will try to prove the LHS. Okay. So, first I write the x of z equation. Now, I will differentiate the term, that is dx of z divided by dz. I will differentiate this x of z. So, what will happen? So, it will give d by dz of summation n equal to minus infinity to plus infinity x of n into z power minus n. Okay. So, now if I differentiate with respect to z, which is the term it will going to differentiate? So, because the only term is z power minus n. So, this will going to be, so the impact on this. So, we will going to differentiate that term, that is minus infinity to plus infinity x of n into d by dz of z power minus n. So, now what is the differentiation of this d by dz of z power minus n? X power minus n. So, just compare it, what will happen? That is minus n into x power minus n minus n, that is minus n minus 1. So, that is what we will going to get, right. So, d by dz of z power minus n. It is a standard expression, that is x power minus n, like that it is there. So, it will going to give minus n into z power minus n minus 1. So, this is what we will going to get the differentiation. So, we will replace that here and we will going to see the result. So, which will give n equal to minus infinity to plus infinity. So, x of n into minus n into z power minus n minus 1. Okay. So, now you can take out this minus n outside, and so whatever the remaining term, that is z power minus 1, you can take outside and you can put it. So, you will going to get the result. So, that is d by dz of x of z, which is equal to minus n into z power minus 1. So, this z power minus 1 I am taking out, and remaining will be summation n equal to minus infinity plus infinity x of n into z power minus n. Okay. So, now here, so we can, this z power minus 1 we can send it this side, so that it will become z into d by dz of x of z, and minus I will take it as here this side. Okay. So, then what is remaining? N into summation n equal to minus infinity to plus infinity x of n into z power minus n. Okay. So, now, so we can write this one. So, that is the z transform of n into x of n, whatever input which is there. So, it is multiplying factor of n. So, this whole expression we can write it as z transform of n into x of n, is it not? So, this is n and the z transform is, so x of n is, so this x of z. So, that we can write it as z transform of n into x of n. So, what is corresponding z transform? It is minus z into dx of z by dz. Now, what is the input signal we need to provide? Which is n into x of n. So, that is what we will going to get here. So, if we have a input signal n into x of n, so then you will get the corresponding differentiation in z domain. Okay. Is it clear? Any doubt? Hello? How to get the differentiation in Z domain? Okay. So now, so initial value theorem and final value theorem. So these two are there. So we'll discuss these two and we'll go to the problems based on these properties. Okay. So that initial value theorem and final value theorem will come later. So based on these properties, we'll going to do the problem. Okay. So that is important in even one problem they will ask in the properties based on the properties. Okay. What are all the properties we have discussed? Based on that property, definitely one problem it will come. Okay. So that's why we'll going to discuss this how to apply these properties and to find out the Z transform. Okay. Now take this one using your property. Okay. Using the properties of Z transform. Okay. Using properties of Z transform, find the Z transform of x of n which is equal to u of minus n. So now which property we will going to use? This one,
Time reversal.
yeah, time reversal you have to use. So anyhow x of z we know for the u of n. Okay. So u of n is, so you can directly do that. So u of n into z of minus n, u of n is 1 which is equal to n equal to minus infinity to plus infinity z power minus n. So this we can write it as 1 over 1 minus z inverse, right? Is it not? So this is a x of z for u of n. Okay. So now but we have u of minus n, right? So wherever the x of z of this u of n is there, so we can have the u of n corresponding z transform, so which is equal to 1 over 1 minus z inverse. Now so if we have the time reversal wherever n is there, so it will go 1 by z, right, in the corresponding z transform, is it not? So that is what time reversal property we have seen here. You can see wherever x of minus n, so if n is changed to minus n, z will change to 1 by z, right? So that property you need to use and you have to do it. So now wherever z is there, you put it as 1 by z. So this will give corresponding z transform as 1 minus 1 by z inverse. Okay. So this will give again 1 over 1 minus z. So this is what the z transform of the u of minus n. Is it understood? Hello.
Yes, sir.
Okay. So you have to put x of z, the x of z which is equal to 1 over 1 minus z if the x of n is u of minus n. Okay. So then what about the ROC? So here for this case what is ROC? Z inverse should be less than 1. Okay. So in this case it will be 1 over r, right? So whatever r it will come, it will be 1 over r. So 1 over r means we will going to get the magnitude of z should be less than 1. So here z inverse it will be less than 1. For this case z should be less than 1. That is the ROC. Okay. So this is one problem, and now you can put this one, try to do this one. That is x of n which is equal to 3 into 2 power n into u of minus n. Which one you will use?
Time reversal, sir.
Yeah, one more property you need to use to think of that what actually, because there are two
Linearity.
yeah, so because there are two signals, this is one
Yes, sir.
this is 1, right. So that's why you need to use both linearity as well as time reversal property. So try to tell me the answer, try to apply that and get me the answer. First, which one you will going to apply? So here first you need to rearrange this one, okay. So instead of 1 by 2, so that is 2, I can put it as 1 by 2 whole power minus 1. Can I put like that? So here instead of 2, I will put it as 1 by 2 power minus 1, this whole power n, right. So this term I can write it as half power minus n, right. So this term which is combined with this u of minus n. So now in general, so before reversing of the time, if we have the x of n, okay, which is equal to half power n into u of n, what is the corresponding z transform? The corresponding z transform for this, which will be equal to 1 over 1 minus 1 by 2 into z inverse, right. Yeah. Now you apply the time reversal, because it is minus n in our arranged that is rearranged signal, we will be having 1 by 2 into 1 by 2 power minus n into u of minus n. Now if you apply the time reversal, then you will going to get the corresponding z transform for this, that is 1 by 2 power n minus n u of minus n. Now its z transform, what you need to do, wherever z is there, you replace it as 1 by z. So that is, you will going to get 1 minus 1 by 2 into z. This is what the z transform of this signal. So now after that, what you need to do, using the linearity property, we will going to scale. So you will going to get 3 into half power minus n into u of minus n. So this corresponding z transform will be multiplying in the, so this scaling factor, same scaling factor will going to multiply here also, 1 over 1 minus 1 by 2 z. So this is what the z transform of the given signal. Is it clear? Any doubt in this? Hello? Hello?
No, sir.
Okay. Okay, so now try to do this one. X of n, which is equal to n square into half power n into u of n minus 3. Which one you will going to apply first?
Time shifting.
Yeah, so you need to apply time shift, because it is u of n minus 3. You need to arrange in such a way that it should also having the same thing. So now I can rearrange this one, n square here. So in order to get n minus 3, I will put half power n minus 3 plus 3, okay, into u of n minus 3. So now this half power plus 3 I will take out, so that will give 1 by 8 into n square into half power n minus 3 into u of n minus 3. Now this is our the given signal which we have put it in a comfortable manner. Now you can find out first the Z transform of this shifted signal. Okay, first we will going to have the half power n into u of n, that is a standard result which we have or available, which is equal to, so this is already we have known and find out, okay, that is 1 over 1 minus 2 into Z inverse, right. Now if we shift the signal, okay, so what is the corresponding Z transform? So whatever the shifting value is there, so that will become a multiplying factor in the Z domain, right. So that is what, half power n minus 3 into u of n minus 3. Now what is the shifting factor here? It is 3. So then you will get the Z transform correspondingly, which is Z power minus 3 divided by 1 minus 1 by 2 Z inverse. So this is what the Z transform of this shifted signal. Okay, so understood this one, this step till now? Hello?
Yes, sir.
Okay. Now after this, so there is a n factor, that is n square it is there. Now recently we have discussed, so if we have differentiation in Z domain, okay, so which is nothing but the Z transform of n into x of n, right. If we have n into x of n, then there will be a differentiation of, so multiplying minus z with the differentiation of x of z we need to get, okay. Here n square is there, so what we need to do, we need to differentiate 2 times, okay, not 1 time, it is 2 times. So now we have already this signal, so like that is x of n, we will multiply 1 time, that is n into half power n minus 3 into u of n minus 3, okay. Now this is our input signal and I am multiplying factor n. Now this corresponding x of z we know, so this is the corresponding x of z. So this we have to differentiate and then multiply minus z. So then only we are going to get the z transform of this, that is minus z into d by dz of, now obtain the z transform, that is z power minus 3 divided by 1 minus 1 by 2 z power minus 1. So this is what we need to do, okay. So now, so for the simplification purpose, so we will going to do this z inverse, we will take 1 over z and we will simplify, then we will going to differentiate this one. So what we will going to get, so we will going to get minus z into d by dz of, so if I take this is LCM 2z here, I will take this to denominator 2z, and if I take LCM we will going to get, so 2z into 2z minus 1, so this is what in the numerator, and denominator I will put it as 1 over z cube, okay. So now what will happen, so this z cube and z, so we will going to get cancel each other and will remain with that square here, so that will give minus z into d by dz of, so this will be, it will go to numerator, so that is 2 divided by z square into 2z minus 1. So this is what we will going to get in the okay. Yeah, so this is what we will going to get in the simplification. Now we have to apply the z transform for this. the differentiation for this. So how to differentiate? So use the quotient rule. So make it this denominator square and then differentiate numerator. So that's how we are going to do. So minus z into d by dz of 2 divided by z square into 2z minus 1. So if I differentiate this one, you will going to get, so I will take z square into 2z minus 1, this is whole square, denominator square into, so this one denominator into differentiation of numerator. So differentiation of numerator is 0 minus numerator into differentiation of denominator. Again, now if you do the differentiation of denominator, so we need to multiply this and then you have to do. So if you multiply this factor inside, you will going to get 2z cube minus z square. We need to do the differentiation for this. So what you will going to get? So if you differentiate this term, you will going to get 6z square minus, so 2z. So this is what you will going to get the differentiation in the differentiation of the denominator. This is by applying the quotient rule. Now this will go to 0. Okay. So now if you multiply this one, you will going to get 2z into 6z square minus 2z, this divided by the z square into 2z minus 1 whole square. Now this is only one time derivative. Okay. So that is 2 by z square into 2z minus 1. That is, so this is only one time derivative, that is n into half power n minus 3 into u of n minus 3. Okay. So this is one time derivative of this, that is z transform. Now, so in our problem we have n square. Okay. So again we have to differentiate whatever the obtained result, that is n square into half power n minus 3 into u of n minus 3. So again corresponding z transform will be the resultant whatever x of z is there, again you have to differentiate that, that is d by dz of this resultant, that is 2z into 6z square minus 2z. Okay. So divided by z square into 2z minus 1 whole square. Okay. So this is a corresponding result. So now you try to do this differentiation, then finally we will going to multiply this scaling factor, that is 1 by 8 into n square half power n minus 3 into u of n minus 3. So the corresponding scaling factor will going to multiply here, that is minus 8z into d by dz of, so 2z into 6z square minus 2z divided by z square into 2z minus 1. So that is whole square. Now this is the complete z transform of this signal. Is it understood? So you need to differentiate and simplify and put it. Okay. That you need to do. Is it understood? Any doubt in this? Hello? Clear? Again you have to use the quotient rule and then put it on, that is power of 4, and then this you have to differentiate and this one. Is it clear? You will do it now? It will take time. We will go to again some other problem. Is it clear? Hello? Pramod? Rishabh?
Yes, sir.
Yes, sir.
Okay. Brusal Anwar?
Yes, sir.
Okay. Is it clear?
Yes, sir.
You will do the differentiation of this?
Yes, sir. Then.
Okay. Okay. So we will go to the next one. Now, so we will see already given Z transform how to apply the properties, like, so take this problem. So this type of problem will also ask. So given that is x of n, its corresponding Z transform is x of z with the Z transform which is given by z by z square plus 4. That is, so some signal is there, its Z transform is given already. Okay. Now by using this Z transform, you need to use the properties. Okay, using properties of Z transform. Okay. So now find the again Z transform of the following signals. What is that? So first one is y1 of n, which is equal to 2 power n into x of n. Okay. And second one y2 of n, which is equal to n into x of n. So now we know already the x of n, the Z transform of that. Now we need to apply the properties and find out the Z transform of these two signals. Okay. So now we know x of n, so which is given is Z transform x of z, which is equal to z by z square plus 4. Okay. So now if we have 2 power n, so if I multiply 2 power n into x of n, that is nothing but y1 of n. Now what is the corresponding Z transform of this one, that is y1 of z. Now we can see which property we have to use. Which property you have to use? Alpha power n into x of n, right? It is nothing but alpha power n, right? Scaling in Z domain, right? Is it not? Are you getting? So here we have discussed scaling in Z domain. See here. So this whatever scaling in Z domain, can you remember? If we have any alpha power n into x of n, the corresponding Z transform will be z replaced by z of alpha, z by alpha. In our case alpha is 2. So wherever z is there, replace it by z by 2, right? So that is what the property, and now here we need to do the same thing. Here we need to do the same thing, right? Now we have already, so that is x of z, wherever z is there, replace it by z by 2, right? That is z by 2 divided by z by 2 whole square plus 4. So this is what the Z transform of the y1 of n. Now we can simplify this also, and we can write, so that is z by 2 divided by z square by 4 plus 4, and you can take LCM and you can do it. Okay, that is z by 2 divided by z square plus 16 divided by 4, and this 2 and 2 will get cancelled. We will going to get 2z divided by z square plus 16. So y1 of z is nothing but 2z by z square plus 16. That is what you will going to get. So here the ROC is also mentioned. ROC will be z which is less than 2. Okay. So now the corresponding ROC we need to here we need to put it. So instead of here whatever it is there, so we have put it as z by 2. That is, so instead of z we are putting here z by 2. So for this case, so the magnitude of z by 2 should less than 2. So R magnitude of z should be less than 4. So this is what ROC for this particular Z transform. Okay. So is it clear now, this one, first one? Is it understood? Any doubt or any?
Got it, sir.
Okay. Nitisha? Hello, Nitish? Naushin Banu?
Yes, sir.
Got it?
Understood, sir.
Okay.
Yes, sir.
Rakshit?
Yes, sir.
Manoj?
Yes, sir. Understood.
Okay. So now do the second one. Which one you will going to apply? Which property you will going to apply?
The differentiation property.
Yeah, so you need to apply differentiation in Z domain and then arrive the result. Tell me the result. What is the result?
Sir,
Yeah,
minus z into
okay,
z square plus 4 minus 2z square divided by z square plus 4 whole square.
okay. We'll check it that. So now we had x of z, that is equal to t z by z square plus 4, right? So this is what the x of n which is given. So now in n into x of n, which is nothing but y2 of n, we have to find out y2 of z, which is equal to minus z into, you have to differentiate, so this x of z, that is z by z square plus 4, right? Now differentiate this one, which is equal to z into, so z square plus 4 whole square, so z square plus 4 in the denominator into differentiation of z is 1 minus z into differentiation of this one, which is nothing but 2z. Okay, so this will be equal to minus z into z square plus 4 minus 2z square divided by z square plus 4 whole square. Okay, so this again I will write it here, so which is equal to, so now you can see here z square plus 4 minus 2z square, so it will become 4 minus z square, is it not? Minus 2z square plus z square, so it will going to give 4 minus z square, so this minus z is there, this divided by z square plus 4 whole square, so which will be equal to minus 4z plus z cube divided by z square plus 4 whole square. So this is your y2 offset. Is it clear? Have you got it this same?
Yes, sir.
Okay. Okay, so some other problems I'll give, try to solve and get the result. If you don't get, I'll solve in the next class. Okay, so take some 2-3 problems and try to solve these problems. That is x of n, which is equal to alpha power n by 3 into u of n by 3, where n equal to 0, 3, 6. So in order to get this scaling, expansion or compression, n should be multiples of this, so whatever the scaling factor. Okay, so that's why it is given n equal to 0, 3, 6, like that. Okay, so find the x of z. Okay, if x of n, it is this one, find x of z. So this is a first problem. Try to find out by using the, so which property we will going to use? You should use time expansion. Okay, so second one, so we can take x of n, which is equal to alpha power n into u of n by 10. Okay, again where n equal to 0, 10, 20, like that. So this is the second problem. And one more, try to do this one, x of n, which is equal to u of n minus 1 by 2. So here you need to be bit careful. N equal to 1, 3, 5. So apply the scaling and time shifting properties, you can get this. And here applying linearity, and then sorry, this one,
Differentiation.
yeah, differentiation. No, here it is scaling as well as the scaling in time expansion is 1, then you have to apply the linearity. Just okay, here alpha power n is there, na? So alpha power n in the sense, okay, you have to apply again scaling in z domain. Okay, that you need to apply and you have to get it. Okay, is it clear? You try to solve this, and then if you don't get, we'll try to solve in the next class. So try to solve all these three, and then we will going to get, so we'll see the other problems. Okay, so we'll stop here. You try to solve, or else we'll solve in the next class. Okay, wait for a minute.